All right, here we go. Ready? Properties of ratios. Okay. The nice thing about a ratio is that there's sometimes not a wrong way. There's multiple ways of writing a comparison. So if I give this to you as a, oops. Oh, I got to set this up again. Grr. Nope. My thing is blinking over here. So I got to do my smart settings. Okay. Here we go. So if A over B equals C over D is your parent ratio, what are the other ratios that we can get from this? So let's do this with numbers. Let's say that we said 2 over 4 is equal to 6 over, what is this? Well, this would have to be 12. What's another ratio that I could write that would be true? Aaron? So we're not going to reduce. We're going to manipulate those four values. And we're going to create ratios, which are fractions, right? Okay, give me one, Allie. Four over 2 equals 12 over 6. So we know that 2 over 4 reduces to 1/2, as does 6 over 12, correct? 4 over 2 reduces to 2, as does 12 over 6. So that's the first kind. Okay, so if this is my parent ratio, then to flip it, what would I write if I was dealing with variables? How would I write my next one? What would I do to show what she did over here? What would you do? B over A equals D over C. And these are going to be in note cards. Okay? You're going to want to do that. Okay? What's another one that we could do? What's another one that I could do? We're just manipulating what we have, and we got to keep it in terms of fractions. Okay? Sarah? So we're not reducing. Which is true, but remember we want to have fractions. So let's say, no, let's think of another way. Claire? Well, let's see if that makes sense. So if this is my parent, then that means you're saying what with respect to the numbers? Equals 4 over 12. And do we get 1/3 in each case? All right, so case number 2 would be A, thank you, over C is equal to B over D. We want to be consistent, making sure we're always starting with that left one. C over A. And so that's kind of the same thing. Yes. Okay. What's another one? This one, next one might be a little bit harder to see. Would you agree? No, this is wrong book. Would you agree that, again, we're referring to the top one, 2 plus 4 over 4, which tells me I get 6 over 4, right? Is that going to be the same thing as 6 plus 12 over 12, which is 18/12? Well, let's look. What is 6/4? 3/2. What's 18/12? 3/2. So how do I apply that over here with variables? What would I do with the variable portion? Kathleen? A plus B over B equals C plus D over D. I can't remember if there's one more. Well, let me look. Yeah, you don't have to do it with the letters. I mean, with the numbers, just with the letters. The numbers are going to be concrete, and the letters are more of an abstract way. Okay. All right, so those are the 3 that we want. Okay, so here we go. So those are the 3. Here we go. So given AB over DE equals AC over DF. So I'm giving you the parent ratio. What are the proportions do we know to be true? So we're going to use those three cases. So what's one other one that I could write? What's one, Allie? And so if we're going to apply what this drawing is, AB is what? 12 over DE, which is 9, and that equals 8 over X. And so this is the parent one. And so what did you say, Allie, I should write? Okay. And in both cases, the parent one, this tells me that 12x equals 72, which means x is 6. In this case, I get 12x equals 72, so guess what? X still equals 6, right? So if we set these up right, no matter which way we do it, we should be able to get the same value for x. What's another case that I can write? Aaron, did you have one? Was that one? All right, you want to try another one? Can you think of another one? Okay. Sure. Kind of go 12 over 8 or 8 over 12. Just make sure you're consistent. And so again, we'll get 72 is 12x, and x is 6. And what would be the last one that I'd want to show? That's the one that's always just a little bit different. What do you got, Sophia? And so this would give me, what, 21 over 9 is equal to 8 plus x over x, which would be 21x is equal to 72 plus 9x, which would be 12. We back down to 12x is equal to 72, which means x is 6. So all of those manipulate into the same thing. Mary? It just depends on what they're saying. If they're just saying write the formulas, I'm just showing you that they actually will always work in each case. Okay? All right. Find BA and BD. Back? Sure. All good? Okay. Okay, so BD over DA, BD, so let's look at this picture. If I'm telling you this is what I want you to use, look at this drawing. What's going to represent BD? Nope. X minus 3. Because BA is X and DA is 3, so wouldn't it make sense that BD is going to be the total length minus that little portion that's down below? So we're going to want to write X minus 3 over, what am I going to put? Is equal to 18 over 6. All right, so cross multiplying and solving for both BA and BD means that 6 times X minus 3 is equal to 54. I can do one of two things. One will make my life easier than another. I would divide by 6 instead of doing what? Yes. So that means x minus 3 is equal to, and so x is equal to, yeah, not 6, 12. Okay, so let's go back and see what they're wanting. They want to know what BA is. Well, BA is what x is, correct? And so it's going to be 12. And BD, we define BD to be x minus 3, which is 12 minus 3, which is 9. Okay, two cities on a map are 96 miles. On a map, two cities, that doesn't make sense. Two cities, yeah. Two cities are 96 miles apart. On a map, they are 4 inches apart. How many of you have actually looked at a map Because now that there's Google Maps and everything that maps out your course, I don't know how many of you have actually ever seen it. You have ever looked at one? On road trips? Okay. So you know you've got a little scale factor, right? That shows you the distance on the map, what it is in reality. Okay, so that's what we're going to look for. That's called the scale factor. So as long as you're consistent, when you set up your proportion, you'll be fine. So I'm going to say, what? I want to know what's the scale factor. So a scale factor is going to be what makes your two fractions equal, or the proportion to be true. Okay? So I would say 96 miles, or we'll do 4 inches over 96 miles. That's a comparison, right? That means in the scale factor, we want it as reduced as possible. We'll say then, does 4 go into 96 evenly? How many times? 24. So that means on a map, 1 inch represents 24 miles. So we can also write it as 1 inch dot dot 24 miles. Now we could convert the units to be the same, but then that wouldn't really help us, because on the map we want to know what an inch is, right? We don't want to know 1 inch on the map represents how many inches in reality. That would give us nothing. Yes? We will. So what is a scale factor? It's the fraction, or the value, that keeps the proportion true, so that the fractions are equal to each other. Yep, this is a note card one. And I think the next page is what, 6-3? So we're done.